hydrogen bonds. Hydrogen bonds are like covalent bonds. So for example, in water, the two hydrogen are coming together with oxygen H2 and one O. And now when they're sharing in this covalent bond, their electron, the hydrogen has one and the other hydrogen has one with the oxygen. Then the oxygen is pulling a little stronger at these two electrons. And it is now a polar bond, a polar covalent bond, because one is pulling stronger at the electrons as the other ones. That makes it a polar covalent bond. And such a polar covalent bond can be a hydrogen bond, and in that case it is with water. Now the hydrogen has now a little bit positive charge because the electrons, so every one of the hydrogens, has its electron a little bit more pulled away to the oxygen atom, so it has a little bit more positivity. The oxygen is a little bit more negative because it has pulled the electron towards it. And now such a hydrogen bond, these hydrogen are now more attractive to other electronegative molecules. For example, another oxygen atom which is bound to two other hydrogen bonds. So these two slightly positive hydrogen atoms want now to attract another little negative atom. For example, another oxygen atom. Such a bond is only around 5% as strong as a proper covalent bond. And it is not enough to form a new molecule, but it can make a link, for example, between different water molecules with H2O, H2O, HDO, and so on. For example, in proteins or nucleic acid. And a single one is not so strong, but there can be hundreds of them at one bigger molecule, and that they are then collectively important, and they are helping then to give it shape and form of such a bigger molecule stability. And that is important how now such a bigger molecule works in the body. And that is according to Gerald Katorga and Sandra Grabowski's Principles of Anatomy and Physiology book on the page 33 and 34, but this is no medical advice.